We're presenting MuM, Multi-View Masked Image Modeling for 3D Vision at CVPR 2026. MuM is a scalable self-supervised learning objective for 3D vision. It's super simple. We take masked autoencoders, who's been very successful by learning representations from pure RGB images by masking patches and recreating their RGB values. We extend this to arbitrarily many views and have a lightweight alternating attention decoder that jointly propagates information between the frames and then learns by reconstructing the frames. We find that MuM is super simple because we can train on large sequences of views. For our final model, we train on randomly sampling between 2 and 24 views during training. And as you can see in the plot below, the training markers are super stable, going down nicely during training. And we don't have the problem that Croco, which we see as a predecessor to our work, which does this something similar but for 2 views, they require quite high co-visibility between these 2 views, thus enforcing the data that they have to already have some type of annotations to understand whether 2 frames are co-visible or not. As we sample up to 24 frames, it's super simple, and we can just, from many data sets, both video data sets and scene data sets, we can just randomly sample views from the scene, and if you take 24 of them, you will have sufficient co-visibility. Another advantage of our objective is that even if you have no co-visibility, let's say you mess up and you randomly sample from different data sets, and they have really no co-visibility, then the objective just falls back to the masked autoencoder's objective. So most of the work is done by the VIT, or Vision Transformer encoders, which are what we extract, or what's the kind of final product of our representation learnings. And the multi-view information is propagated in the decoder, which is more lightweight and which we discard for most of our downstream use cases. MuM beat the recently released Dino V3 in many of our 3D vision tasks that we evaluate. One perfect task for MuM is feed-forward reconstruction from arbitrarily many views. This is the CVPR 2025 best paper VGT, and we change there and try different encoders. In the VGT, they use Dino V2. We try out Dino V3, Croco V2, and MuM, but in a slightly smaller setup with a frozen encoder and less compute resources. So, but in that context, MuM outperforms Dino V3, and also in a full Roma, which is a feature matcher, dense feature matcher. We replace the frozen encoder, which is in original Roma is Dino V2. We replace that with MuM, and we see improved results. So, as well as other tasks that we evaluate in the paper. All in all, MuM is a super scalable, super simple SSL objective that you can train for however long you want. You don't have to worry about co-visibility sampling. You can sample long sequences from either videos or scene data and have a good mix. No need for any labels. Just find a bunch of frames and train on them. And this makes the model learn in the attention map of the decoder, which has this global attention between all the different frames. You can see that the attention map kind of lights up for matching regions in the clock here, even though I'm kind of covering that part. So that's MuM. Looking forward to seeing you at our poster, and please feel free to ask us any questions there or send us an email.